power series about x equal to a is summation n equal to 0 to infinity cn bracket c minus a power n equal to c0 plus c1 then bracket x minus a plus and so on until infinity. While a power series about x equal to 0 is a series of form summation n equal to 0 to infinity cn bracket xn equal to c0 plus c1 x power 1 plus c2 x power 2 and so on. To test a power series for convergence, first step we have to find the radius of convergence. The second step is to find interval of convergence, and the third step is to prove the second step, which is interval of convergence. And let's proceed to example 1.
Okay, so this is our first example in a power series question. So in this question, we are required to test for convergence and find the radius of convergence and the interval convergence for the series summation n equals to 1 to infinity negative 1 to the power of n times n over 4 to the power of n times x plus 3 to the power of n. To this series, first we'll apply the ratio test, which is limit n approaching infinity a n plus 1 over a n, which is negative 1 power of n plus 1 n times n plus 1 times x plus 3 to the power of n plus 1 over 4 to the power of n plus 1, and instead of dividing by an, I'm multiplying by 1 over an, which is multiply 4 to the power of n over negative 1 to the power of n times x plus 3 to the power of n. And we're including a modulus here so that we can find the interval for x. And negative 1 to the power of n plus 1 is actually negative 1 to the power of n times negative 1 to the power of 1. Therefore, we can remove the negative 1 to the power of n. And the same goes for x plus 3 to the power of n plus 1 and 4 power of n plus 1. And therefore we'll have a limit n approaching infinity modulus negative 1 times n plus 1 times x plus 3 over 4n. And since x is not affected by the limit, we can simply move it to the other side, and modulus of negative 1 will be positive 1, and we can just remove that as well, and now we have modulus x plus 3 limit as n approaching infinity modulus n plus 1 over 4n. And now to solve this, we'll divide it by the highest power in the denominator, which is n. So now we'll have 1 plus 1 over n over 4, and we'll have modulus x plus 3 times 1 over 4. And that is actually equals to rho, and in the ratio test, when rho is less than 1, it converges. So in order for it to converge, modulus x plus 3, 1 over 4, has to be less than 1. And modulus x plus 3 has to be less than 4. And thus the radius for convergence is 4. And based on this, the interval for the interval of convergence would be negative 4 less than x plus 3 less than 4, which is negative 7, less than x less than 1. However, this is not the final answer, as we have to prove whether does it converge at the values x equals to -7 and 1? Therefore, we have to substitute these values back into the series. When x equals to -7, the series will be -1 to the power of n times n over 4 to the power of n multiply -4 to the power of n. And we can split this up into -1 to the power of n times 4 to the power of n. And we can cut this 4 to the power of n. And therefore we'll have -1 to the power of 2n times n. And since the power of -1 is always an even number, this will always be a value of 1, and therefore we can cut that off, and therefore we have a series of summation n equals to 1 to infinity n, which we know it's a diverging series. And at x equals to 1, we'll have -1 to the power of n times n over 4 to the power of n times 4n, and once again we can cut this off, and we'll have a series of -1 to the power of n times n, and this is a alternating series, and therefore it diverges. And so the final answer is this: -1 less than x less than 1, which is the interval of convergence. Okay, so this is our second example for a power series question. In this question, we are required to test for the convergence and find the radius and interval of convergence for the series summation n equals to 0 till infinity n factorial times x to the power of n. And once again, we'll apply the ratio test, which is limit n approaching infinity a n plus 1, which is n plus 1 factorial times x to the power of n plus 1 times 1 over an, which is 1 over n factorial x times n. And we can actually split this out into n factorial times n plus 1, which we can then cut off the n factorial along with this. And we can actually split this up to x to the power of n times x, which we can then cut off the x to the power of n. And we multiply this in, and we have n plus 1 times x along with the modulus. And once again, we'll move x to the other side since it's not affected by the limit. And we'll have x modulus x limit n approaching infinity n plus 1. And as you solve this, you'll get the value to a infinity. And now you have x times infinity, and therefore this series diverges at any x value except for x equals to 0, because if x is equal to 0, even infinity multiplied by 0, you'll get a 0. So yeah, this is the answer.